This episode of DNews is brought to you by Domain.com.
The sun's just a boring old glowing ball in the sky, right? So wrong. Hey y'all, Amy here, bringing you some sunlight on DNews, or at least knowledge of it. Recently, NASA's Solar Dynamics Observatory took its 100 millionth observation of the sun, and to celebrate, the mission team released a gallery of some of their favorite solar images, and most of them don't really look like the sun we're used to seeing. Why is that? So first off, it sort of goes without saying that you should never look directly at the sun because it will seriously damage your eyes. Always use eclipse glasses or special filters on a telescope or binoculars. So if someone were to ask you what color the sun is, you'd probably say yellow, right? Or maybe orange or pink if you're seeing it at sunrise or sunset. Well, the sun looks yellow because of our atmosphere. If you could look at the sun in space, it would be a white ball. But it doesn't look like a boring old white ball in these pictures from SDO, you say. That's because SDO can see far more than our eyes can. The spacecraft has 3 instruments. The helioseismic and magnetic imager measures the ripples and magnetic field on the visible surface of the sun. The atmospheric imaging assembly designed to measure the sun's atmosphere, and the extreme ultraviolet variability experiment that tracks the extreme ultraviolet rays the sun sends our way. Not only do all these instruments look for different things, they look in different wavelengths of light. We see invisible light, which is a tiny part of the electromagnetic spectrum. As light waves get longer, you get into infrared, microwave, and radio waves. On the short end, you get ultraviolet, X-rays, and gamma rays. So each instrument on SDO sees in various wavelengths. But that's not all. Since it launched on February 11th of 2010, SDO has captured some incredible occurrences up close and in various wavelengths, like coronal mass ejections, which are massive bursts of solar wind and magnetic fields rising above the corona. And when you take all these observations and put them together, adding the X-ray observations of coronal activity to the infrared, you get these amazing and exciting pictures that show you just how dynamic our sun really is. So, will you look, indirectly of course, at the sun any differently now? Let us know in the comments below, or you can catch me on Twitter as AST Vintage Space. And don't forget to subscribe for more DNews every day of the week.